These are the notes for Algebra 2, Section 3.2, Part 1 in your textbook. I've split Section 3.2 into two separate parts. It covers, the entire section covers page 160 to 163 in your textbook. The first part of Section 3.2 deals with solving systems of equations using this method of substitution. Now, the substitution method for solving a system of equations requires you to solve for one variable and then substitute that variable into the other equation. So we have three steps to work with when we're doing the substitution method. Step 1 is to solve one of the equations for one of its variables. Doesn't matter which equation you solve for which variable. That's up to you. Step 2 will be to substitute whatever expression you got in step 1 into the other equation and solve for the other variable. At this point, you will get a single number answer. Step 3 will be to take that single number answer, that value from step 2, and put it into the revised equation or to any of the equations from step 1 and solve. Usually the revised equation is easier, but not necessarily. By revised equation, what I mean is the equation that we got from step 1. Now, it's a lot of information to take in, so let's do some practice problems to see exactly what I mean. We are going to solve this system of equations, 2x plus 5y equals negative 5 and x plus 3y equals 3, using the substitution method. My first step will be to solve for a single variable. As I said, it does not matter which equation I use or which variable I solve for. What I usually want to do is look at both of my equations and find a variable that it would be easy to solve for. For instance, in this system, solving for this x would be easier than solving for anything else. Solving for this x would require me to divide by 2. Solving for this y would require me to divide by 5. And solving for this y would require me to divide by 3. But solving for the x that I have circled does not require me to divide by anything. So it will probably be easier to do. I'm going to take my second equation and I'm going to solve for this x. So I have x plus 3y, make that look a little bit more like a y, equals 3. That is the equation I want to solve for this x. Solving for this x means all I have to do is subtract 3y. And I'll do it from both sides because I have to. On one side, x equals. On the other side, I cannot combine 3 and negative 3y because they don't have exactly the same variables. Instead, I simply write 3 minus 3y. So I have solved for the x variable. What that means is that in the other equation, 2x plus 5y equals negative 5. Wherever I see x, right here, I can substitute in 3 minus 3y. And that's what I'm going to do. I'm going to rewrite my equation substituting in 3 minus 3y for x. So it will be 2 times 3 minus 3y plus 5y equals negative 5. So x has been replaced by what I got in the first step. Now I need to solve this equation. Since I only have y's in this equation, I should get a single number answer. I start by distributing. 2 times 3 is 6, minus 6y plus 5y equals negative 5. I can combine negative 6y and positive 5y and get negative 1y. So 6 minus 1y equals negative 5. I need to solve for y, so I will subtract 6 from both sides. Negative y equals negative 11, so y must equal 11. This thing is kind of in the way, so I'm going to scroll it down. Y equals 11. Now what that means for us is that since I know that y equals 11, I can take y and plug it back into the equation I got from step 1 and get the number for x. So I'm going to start by rewriting the equation from step 1. I will rewrite x equals 3 minus 3y. Now wherever I see y, I'm going to plug in 11 because y equals 11. X equals 3 minus 3 times 11. This is order of operations. I'll simply solve that. I have x equals 3 minus 33. So x equals negative 30. That means that the solution to this system of equations is negative 30, because that's my x value, and 11. This is a point in x, y. All of our answers should be given as a coordinate point x, y. X comes first, y comes second. We follow these steps for every system of equation, for every system that we're solving by substitution. So, in the next, on the next page, we're going to see a problem that you need to solve using this process. Solve one equation for one variable, substitute that expression back into the other equation, and then, once you have a single number answer, plug it back into the equation from step 1. Here's the system. X plus 2y equals negative 2, and 3x plus 4y equals 6. Pause the video. Use those steps to find the solution to the system of equations. When you're done, unpause the video and we can see how you did. Alright, here we go. Now you can see I chose to solve for this x because it looked like the easiest one to solve for. All I had to do was subtract 2y. I got x equals negative 2y minus 2. I plugged that into my second equation wherever I saw x. So I had 3 times negative 2y minus 2 plus 4y equals 6. Distributed, combined like terms, and I got y equals negative 6. I took negative 6 and I plugged it back into the first equation. I could have plugged it into the equation I got in step 1, but I chose to plug it into the original equation. What we would see is that I'll get the same answer either way. So it does not matter where I plug this y back in, as long as I work out the algebra correctly. When I plugged it in, I saw that x equaled 10. So my solution was the point xy, 10, negative 6. Alright, we're going to do a couple of more examples. These are exceptions to the rule. Now, we saw before, when we were graphing systems of equations, that we could either have an equation that has exactly one solution, we could have equations where 2 lines sit directly on top of each other, or we could have a situation where the 2 equations didn't touch at all. The 2 lines were parallel. And we're going to see how that looks using the substitution method. I'm going to start by picking an equation and a variable to solve for. I'm going to solve for this x because it looks easiest. So x minus 2y equals 4. I want to solve for this x, so I'll add 2y to both sides. And I get x equals 4 plus 2y. That's my first step. Now I have these what x equals. So in my second equation, 3x minus 6y equals 8. Everywhere I see x, I replace it with the value that I got for x. 4 plus 2y. Minus 6y equals 8. I need to distribute. 3 times 4 is 12, plus 6y minus 6y equals 8. Six y and minus 6y will combine together, and I'll get 12 equals 8. But of course, 12 does not equal 8. So that is a problem. What that means is that there is no solution to this system of equations. These two lines will not intersect. There is not a solution. And we don't need to go any further in this problem. Alright, we're going to look at this equation, this system of equations here. I have 12x minus 3y equals negative 9. Negative 4x plus y equals 3. First things first, I need to pick a variable that I want to solve for. None of these, 12x, negative 4x, negative 3y, look like they'll be easy. But y looks like it will be easy to solve for. So that's what I'm going to do. I'm going to solve the second equation, negative 4x plus y equals 3, for y. To do that, I'll simply add 4x to both sides. And I'll have y equals 3 plus 4x. So in my second step, wherever I see y, I'll plug in 3 plus 4x. I have to use the other equation. I cannot use the same equation twice in a row. That would just have me going in circles. So I use my other equation, 12x minus 3y equals negative 9. I'm going to replace y with 3 plus 4x. And that equals negative 9. Again, I will distribute. I'll have 12x minus 9. Negative 3 times positive 3 is negative 9. Negative 3 times 4x is negative 12x. And that equals negative 9. And now we can see here, I have 12x and negative 12x. Those two cancel out, just like in the last problem. 12x minus 12x is 0, so I have negative 9 equals negative 9. Well, negative 9 equals negative 9, that's a true statement. That's always true. Negative 9 always equals negative 9. Therefore, we have infinitely many solutions. And if we had graphed these two lines, they would have sat right on top of each other. The last system that we did, where the two did not equal each other and there were no solutions, the two lines would not have intersected at all. Here, they are sitting directly on top of each other.